from Hindustan College of Engineering and Technology. Now we are doing POC for TechGM. For that, we developing a wind regenerative system for EV charging using air pressure. We developed a battery charger that system supports low voltage function in EVs. It is designed for charging batteries typically for 6 to 60 volt. It has provides automatic charging control. It is compatible with various voltages like 12, 24, 36, 48 and 60. It is also feature overcharge protection which prevents battery from drain too far, overcurrent protection which includes to prevent the batteries too quickly or with excessive current which could result in overheating or battery damage. For that, we introduce an automatic charging control that system managing the charging process according to batteries state of charging using algorithm like constant current or constant voltage to ensure optimal charging for longer battery life. It supports both constant current and constant voltage mode, provides smart and efficient charging. It has LED indicators to display charging status, charging, fully charged or error status. It has thermal protection, it has voltage monitoring function, it has protection against short circuits, it has compatible with lead acid, lithium ion and lithium ferrophosphate batteries. It has switching frequency around 50 Hz. A feedback loop is used to adjust duty cycle of switching, ensuring the output voltage remains constant even the output voltage or load condition change. The output voltage smoothen out using capacitors to reduce ripple and provide a stable DC output. The FEA analysis of wind turbine involves dividing a complex structure of system into smaller, simpler parts called finite element. This process is called meshing. We fix boundary conditions like displacement, force and thermal conditions. The converging equation involves heat transfer and fluid dynamics to solving the system equations like displacement, strain and stress. The post-processing process are displacement plots, stress strain and distribution, temperature gradient and vibration modes. It provides 3D visualization of how force are distributed through the structure, highlighting the area of high stress or deformation. The CFD analysis of wind turbine simulates the behavior of fluid, liquid and gases, and they are interact with solid surfaces to move through the boundaries. These CFD using compressible fluid like air. This CFD solving Navier-Stokes equation which describes fluid velocity, pressure, temperature and density by meshing to dividing the fluid domain into smaller and simple pieces. These rigid plate wind turbines are to capture the kinetic energy from wind and convert into electrical energy. The maximum energy will be captured. It can handle high stress including gust wind, which make them highly reliable over long period. The vehicle CFD analysis is the use of computer simulation to study and analyze the flow of air around the vehicle. It helps to understand how airflow impacts vehicle's performance, aerodynamics, fuel efficiency and safety. The aerodynamics to understand air interact with vehicle to reduce drag, increase downforce and improve fuel efficiency, and also find vehicle stability and handling, and also cooling and thermal management. We use CNC machining and laser cutting for manufacturing a wind turbine blades and its structures, and also we making the parts of molding cavity of wind turbine blades. We use two machining cavities of wood pieces for bending a turbine blades to induce pressure on both surface of blade. By tightening the screws, the blade will turn to bend. We tested our prototype in various velocity of air conditions. We tested the RPM of wind turbine. The RPM will be measured by tachometer. The wind velocity will be measured by anemometer. By using this value, we find the torque of our wind turbines. The torque of our wind turbines, which is around 0.49 Newton meter. By using this wind regenerative charging system, we can achieve necessary voltage to effectively charge the EV batteries. This wind regenerative system is simple and cost effective, and it is easy to maintain and manufacture, and also it is compact, so we can fix this device in front region of EV under the front hood.